Okay, hi everybody. My name is Colin Williams, and I'm going to be doing a presentation on malware analysis using Vivisect. So Vivisect is a Python framework. It's cross-platform. It'll run on all three major operating systems: Windows, Linux, and Mac, and probably anything else that Python will run on. It consists of three components. The first is Vivisect itself, which is an interactive disassembler, similar to GDB or OllyDebug or anything like that. Second is Vtrace, which is a Python debugging module or library that you can use in your own Python scripts. And then the third is VDB, which is just a command line debugger that uses Vtrace behind the scenes. Now, unfortunately, Vivisect in general does not have good documentation. So, just as an introduction to Vivisect, as I mentioned, it is a disassembler. It contains GUI that you can use. You'll see an example over here. You use it for static analysis, and then if you need to do dynamic analysis, you can launch VDB through the interface. VDB is the command line debugger. You can use it to execute a program and step through it, add breakpoints, all of that. It uses the Vtrace API behind the scenes. So you can do basically everything in VDB that Vtrace can. And then you can also import your own scripts to do custom functionality. Vtrace is a Python module or a Python library. It has a fully functional debugger that will let you control the program execution. You can also add breakpoints, of course. You can do that on memory locations, expressions, or any particular memory access. And then you can run custom code whenever a particular event occurs without needing a breakpoint there. So the process of installing the Vivisect suite is to install Python 2.7, then you install Qtpy, and then you go download the latest release of Vivisect, and you can optionally copy the Vivisect files into the Python installation directory just to make it easier to refer to them. And I'll have another video going through the process of installing Vivisect itself. In order to use Vivisect, and this is the Vivisect tool, not the suite, you're going to run Python vivbin and then the file name that you want to analyze. And then usually you're going to want to load the default view using the view menu and then layouts and load, and browse to your Vivisect installation directory and select the Qt and default layout. So Vivisect contains a bunch of different windows. These are just a few of them. It'll display all of the strings found in the binary in one window, display all of the code and data segments in another. It'll display all of the function imports and exports that are used and provided, and then list all of the known functions that it could find in the binary itself. The next window is the Vivisect function graph, which is a really neat window. It displays assembly of a particular function, but it breaks it up based on the potential code paths that can be taken, and it links those together. So it's looking for the jumps in the assembly, essentially. You can use this to comment sections of code by right-clicking, I believe, or you can rename locations that are referred to, anything like that. Then you have the basic assembly window, which is going to display the actual assembly that's being used in the program for a particular function. It has syntax highlighting, cross-referencing, and then you can do the same location renaming and commenting of sections. And anything you do in the other window, in the function graph window, will also display in here and vice versa, so it keeps it in sync. Alright, so in order to use VDB, you're going to run VDB bin in Python, and then you can kick things off with either the exec or the attach command. Exec will execute a new process and attach to it. Attach will attach to an already running process. Obviously, attach is going to be subject to the security model of your operating system. Once you're in, help will display a command list, or if you're on help space command, that'll give you help for a particular command. Some of the more popular commands are BP, which will let you add, remove, or manage breakpoints. Dis will disassemble around a particular address. Mem will print any section of memory, and you can optionally format that in any manner that you want, say as a string or an integer or pointer or anything like that. Write mem will let you modify memory. Step I will step one instruction forward after hitting a breakpoint, and then script will let you run a Python script that, like an external Python script, in the context of the debugger. So you can use that to automate some steps. Alright, so using Vtrace, again, since it's a Python module, you're going to need to write your own Python script to do that. First steps are import Vtrace and optionally VDB if you want to use the VDB functionality as well. Then you create a trace object, as you can see, and then execute a trace on a particular program. Now this one, doing this doesn't let you attach to an existing program because you just provided the file path. Executing a trace doesn't actually execute the program itself, so you can safely do this. Next, in your script, you're gonna set up breakpoints, define functions, do whatever you want to do as sort of pre-initialization work before actually running the program. And then calling run on the trace object will run the program itself and start doing the actual debugging. Now, if you're working on some malware, calling trace.run will actually run the program, so you need to be careful with that.